Good morning, everyone. Welcome to this magnificent Math Monday. I wanted to get started with this idea about transformations of functions, and particularly looking at, what are the four different numbers that we can have that are involved in transformations? Let me just put down the transformation form here. We have y is equal to a multiplied by some f, and then we can have a k in here multiplying some, well, we usually put this k on this side, k multiplied by x minus d plus c, okay? And we have these four numbers, a, k, c, and d. And we sometimes write this x minus d, and sometimes I would write this x plus d, okay? It's addition and it's subtraction. It could be any of those things, right? So anyway, let's just take a look at that. That's what that looks like there. What do these four numbers mean? What do they do? Well, let's recap. We're going to recap today. I would encourage you to take down this table and to build this table somewhere into your notes where you can build your understanding and just kind of really zero in on what these numbers mean. There's two things we can do to the numbers of a function, and there's two places we can do it. When there's two places we can do it and two different things we can do, that gives us four options because it's 2 by 2. So we can either multiply or divide to these numbers, and we can either add or subtract to these numbers. And which are these numbers? Well, we're talking about outputs or we're talking about inputs. You're either doing this to the y value or to the f of x value, or you're doing it to the x or whatever your input is. Maybe it's t for time, maybe it's d for distance, maybe it's q for number of times someone raises their eyebrows. I don't know. It's some independent variable. So if we're multiplying or dividing, and we're doing that to outputs, that would be this number here, a. A is multiplying outputs. So that's the number a. And the effect of a is to, as x gets bigger, so as a gets bigger, it increases the vertical stretch. It's important to remember that this is vertical. You might even draw an arrow like this saying stretch, an arrow in both directions. That's the effect of multiplying your outputs. A negative value will reflect. It'll reflect vertically. It'll reflect through the x-axis. You might draw a little picture here, and you might say that's going to reflect this way. It's going to reflect in the x-axis. If we multiply inputs, on the other hand, multiplying inputs is a little different, where if we take this k number, there we're multiplying the input. And when you multiply an input, something different happens. This is going to give us horizontal instead of stretch. The effect of k, what happens to the horizontal movement of the function as k gets big? Yeah, it squeezes everything towards the y-axis. That's kind of counterintuitive, because when we multiplied outputs, it stretched them away from the x-axis. Here, as k gets bigger, it squeezes towards the y-axis. So we call this horizontal compression. Okay. And then if we have negative values of k, that's actually fairly predictable. I mean, that's pretty intuitive, where a negative value is a reflection around the y-axis. So there you might draw a little picture of a parabola that's been moved over here, and it would reflect over there. It would reflect to the other side of the y-axis. I had a little hand spasm, and my parabola is very ugly. Anyway, it's just going to turn around that y-axis point. Cassidy?
I can't see the parabola.
Yeah, it's better if I draw some in Desmos, isn't it? Yeah, so here would be what that would look like. I could have y is equal to, if I reflect x squared in the y-axis, that's not going to give me much. It's just going to be the same thing. But if because it's indifferent to being reflected through the y-axis, it's already symmetrical around the y-axis. But if instead I had y is equal to x minus 3 squared, now watch what happens with this one. Here it has the point 0.9 as its y-intercept. If I go ahead, and I'm just going to take this, copy, and put it in here and make this x negative. See what happens. Oop, there. So that's like a negative k transformation being applied to it. Now this has reflected around this point. This point here, the vertex, was once at 3, 0. Now it's over here at negative 3, 0 over here. So there's a reflection through the y-axis. That's what that will look like. You can see that one, eh, Cassidy? Cool. Okay, so that's the effect of a negative k, is to reflect in the y-axis. Now let's go back to these ideas here. We can also be adding or subtracting to our inputs or our outputs. We've looked at multiplying or dividing, and those are the numbers a and k. If we look at adding or subtracting, remember, addition and subtraction, they're the same thing. They're just in different directions. Multiplication and division, again, the same thing. They just happen on the top or the bottom of the fraction. So if we add or subtract to our outputs, that's the C value. That's saying, give me the output of this function and then add something to it. Those work quite predictably. As we increase C, it translates the function upwards. Translation upwards or downwards. Upwards is addition, downwards is subtraction. So this is translation plus is upwards, and minus is downwards. Here some arrows might be helpful. I'm either going upwards or I'm going downwards. But I'm not arrow in both directions, stretching it. I'm just moving the whole thing up or down. So it works very well for those of you who want to do an interpretive dance. You can distinguish between A and C in that way. Okay. With D values, there's where I am adding or subtracting to X values. And notice sometimes we write this as X minus D in the transformation form, but you could equally write it as X plus D. Doesn't much matter how you write that, but it's important that you understand that when we look at D, this is the number, oops, that's a B, Mr. Jennings. D is the other way. I had to practice that for a long time in grade 1, getting my D, lowercase d and lowercase b distinguished. I still sometimes make the mistake. So lowercase d is here. This is translation horizontally. So a positive number here, if I'm ultimately doing x plus some number, that actually moves in the counterintuitive direction towards the left. So a positive number in there, D, is towards the left. And a negative number there is towards the right. And those are the 4 things that I can do to a function. I can multiply or divide outputs or inputs. I can add or subtract outputs or inputs. And that gives us a guideline to how I do that. Now today we're going to be looking at examples where we do multiple transformations of a function at once. Diego?
What does it say for C?
For C here, this is translation, either going upwards when I have a positive number that I'm adding.
Just look like translation.
Translation. Yeah, there's an N in there, isn't there? That's strange that I don't have that N. Let's get that N in there. Make a little space for it. I have to translate some letters left and right to translation. Translation. There. Okay. Now, when I'm applying a series of transformations to a function, there I want to apply these transformations in the right order. So these are some questions that you'll work on in just a moment after I do an example with you. Let's have this function. F of x is equal to 2x squared minus 8x plus 6. And I want to have a transformed version of f of x that involves here a vertical stretch of 3, a reflection in the y-axis there with a negative k, and then a translation 2 units to the right. So first, if I'm going to do this, I'm going to need some kind of flowchart where I can get all of these things right. And here's a flowchart that I have for you. First thing to do, sketch your original function. Label at least 3 points. You could even create a table of values for your original function. Now we are looking at examples where simple parent functions are not our original functions. We're going to start with already transformed functions and then apply a series of transformations to them. The next thing to do is really get clear in your mind the series of transformations you need to do to these functions in order to successfully create this transform function. And then apply those transformations point by point. You're going to have at least 3 points that are labeled on your function. You're going to apply these transformations to each one of those points and then sketch the new function. And then the last thing that I'm asking us to review today is to calculate some inverses. So let's do that with this function here. So get down this example in your books. First thing that I will do is create a table of values for f of x. And so to do that, I might have something that looks like this. So let's bring this over here and zoom in. Okay, so I am going to be graphing f of x, which is, let me close this, 2x squared minus 8x plus 6. Am I really that in your way, Camden?
No, I just have to get it.
Okay, all right. So here, let's go ahead and graph this one. Yeah, I'll move this over here. There, that's lots of space, Mr. Jennings. So how would you go ahead and graph that? How would you do that first? Would you guys start building your table of values, or would you factor it, or what would you do to that first? For me personally, I am going to look at this, and I know 1 point already. I know that when x is 0, y is 6. So there's my y-intercept. So I go ahead and I plot that. 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6. There it is. There's the point 0, 6. And then I don't have the vertex over here. I don't have the roots. So how would you get those? Sorry? Yeah, you can go ahead and factor it. So factoring it allows us to find the roots. Let's do that. I'm going to do this work in black because it's all f of x. So the first thing that I'm going to have is I'm going to look for the factored form. F of x is equal to 2 multiplied by x squared minus 4x plus 3. What are two numbers that multiply to positive 3 and add to negative 4? Excellent. Negative 3 and negative 1. We'll do that. That gives me the roots. So I might write down the roots over here right away. And I'm just doing these in a different color so it stands out a bit better against my my stuff. So this is x is 1, y is 0. Remember, these are sign flippers. I have to flip these signs because when x is 1, 1 minus 1 makes a 0. And when x is 3, 1 minus 1 makes a 0. So I can also find the vertex using this. How could I find the vertex in a tricky manner using these roots? So I know that x is 1 is one of these roots. It's right here. That's 1, 0. And then another one of the roots is there. So I already can see this parabola is going to do something like that. So where's the vertex going to be?
At 2.
At 2, yes. So I know that the vertex is a key point. I might as well get that in my sketch. It's going to happen at 2. I could do that here by negative b over 2a. So negative b would be 8, not negative 8, but 8 over 2a. 8 over 4, that's 2. So that's one way to find it, is using that part of the quadratic formula. Negative b over 2a will give you the axis of symmetry. That will give you the x value of your vertex. But I can also look at the roots, and I can calculate the average of the roots, the midpoint of the roots. That will also find the axis of symmetry, because the roots will be symmetrical around the axis of symmetry. So I know that's 2. And then the last thing I could do is complete the square here, and that will give me the coordinates of the vertex. But let's just plug in 2 into our formula, and we could use this one or this one to find it. 2 minus 1 is 1. 2 minus 3 is negative 1. So this is 1 multiplied by negative 1 multiplied by 2. So that's going to be at negative 2. So the vertex is down here at 2, negative 2. And so I can plot that point. There. Now I have everything I need to make a nice sketch of this parabola. Let me do my best here to make a beautiful sketch using my mystifying technology, which is still a little bit mystifying to me. Yeah. I'm right off the edge of the desk, that's why. And watch as I demonstrate a growth mindset and learn in front of your very eyes. Whoa, that is so ugly, Mr. Jennings. Okay, I'm going to have to do that in another way. I'll show you in Desmos. I don't know why I can't do this today. You'd think I would have time in my personal life to practice using this technology, but it never seems to come up. As soon as I bring it out, my daughter wants to draw pictures. All right, so now I've done step number 1. I've sketched the original function, nearly. Just I can do it with a pencil. For some reason, can't do it with this today. And next, I want to summarize the necessary transformations to transform f of x into a new function, g of x. So here's g of x. I want to multiply everything by 3, and then I want to reflect everything in the y-axis, and I want to move everything to the right by 2. Okay? So in order to do that, I could take a new table of values and stick that in near this table of values and translate these different points that way. I can do that there. Okay, so what order do I have to do these transformations in? Does it matter what order I do things in? For reading the transformations? That's funny, actually. You could just read from left to right and do that. But that's a coincidence. What are the transformations? What are they ultimately doing to functions? Sorry?
Transforming them.
They're transforming them, but what does that mean to transform the function? Like, what are we doing to the numbers?
Multiply, dividing, adding, subtracting.
We're either multiplying or dividing, adding or subtracting. Does it matter what order you do those things in?
Yeah.
Bedmus. Yeah, so what order should I apply my transformations?
The left side, multiply, divide. Then minus subtract.
Apply your A and your K values first. Apply your C and your D values next. Doesn't matter what order you do A and K or C and D. A is only going to affect Y values. K is only going to affect X values. C is only going to affect Y values. D is only going to affect X values. You do these, and then you do these. Sorry, you do these, and then you do these. So let's do those. All right, so the first thing that we'll have to do, we have a negative K here and a positive 3 for the A. So I might summarize these transformations for my own brain so that I can go through. This is going to be A is equal to 3, K is equal to negative 1, and I have no C. But I have a D is equal to ultimately negative 2. I'm really uncomfortable with saying this is X minus D, which is how it's often presented to students. And the idea there, we present this as X minus D to students because the movement of D is counterintuitive. When I subtract, it tends to move in the positive X direction. When I add, it moves in the negative X direction. It's backwards. And so we try and remove that backwards nature with this minus, okay? I understand this is D is minus 2, and then I remember it's a sign flipper. That's because I have an understanding of these. So I would encourage you to look at it that way as well. Okay, so here are my transformations, and I can think of these as transforming the points in f of x, and a point in f of x, it would just be, an xy. An xy that's in f of x is going to transform in this, according to this formula here. In g of x, I'm going to have 3 multiplied by my y. So that's like 3y. There's no c, so I'm not doing anything to that. But with the x's, I'm going to have negative x because of the k, and then I'm going to subtract 2. Okay? And it's going to look like that. These points are going to transform in this way. So let's try that. For y here, 0, 6, okay, I need to multiply that by 3. 0, 6. That should map to 0. Oh, wait. Yeah, 0, 9. Sorry, 18. But here, this 0, that's not correct, Mr. Jennings, because you need negative 0. Oh, right, negative 0 is just 0. But then I need to subtract 2 from it. So that would be minus 2. So this is expand that 3 times in the y, and then reflect it over the y-axis with the negative k, and then subtract 2 from my x. Oh, a d of negative 2? Yeah, that moves it positive 2. I have to remember that's a sign flipper. Diego?
So even with like the other like kind of little chart you did, I didn't understand how you got your like x and y like.
Oh, here? This one here?
No, like what you're doing right now. Like,
Okay.
I didn't understand where you got 18.
Oh, 18? So I know that I need to stretch this 3 times vertically.
But, like,
So something that's at 0, 6 is first going to stretch to 0, 18. Sorry?
I'm confused.
So this A is going to be multiplying the outputs of f of x. 6 was one of those outputs. That gets multiplied by 3.
Oh.
Yeah. And that's the function of this A here. And then I reflected in the y-axis, but that didn't do anything. And then this is x minus 2. So that's actually going to be adding 2 to these x values, because this is a sign flipper here.
How come the negative k didn't do anything?
Because it was at 0.
Oh, okay.
If I did the 2 first and then I flipped it in the y-axis, you would see then I'd be making a Bedmes error.
Yeah.
Okay. Now let's take another point. 1, 0. So 0 stretches to 0 according to 3, and then I flip it in the y-axis. So that means I multiply this 1 by negative 1. So that's now negative 1x, and then I add 2 to it. So that's actually now the point. It's actually mapped back to itself. 1, 0. 3, 0. Okay, the y again stretches by factor 3, but that's a 0, so that doesn't stretch. And then it goes to what? Then 3, I make that negative, so negative 3, and then I add 2 to it, so that becomes negative 1, 0. And then the last thing, 2, negative 2. This has both a non-zero output and an input and a non-zero output. So let's first stretch this negative 2 to negative 6. Let me just... Oh, this here? Okay. Yeah. Uh-huh. There. Okay. So that's a lot of vertical and horizontal compressions and a vertical translation. So 2, negative 2. First thing I do, multiply the y by 3. So that's negative 6. And then that's the only transformation that I'm doing to y. So I could even put that into my table of values now, negative 6. And then this 2, I'm going to make it negative. So that's now at negative 2. And then I'm going to add 2 to it. So that actually went to 0. Okay? This was the vertex here. This was the old vertex. It's still the vertex of the new transform function. These two were the roots. Notice that the roots are actually, they end up still being the roots because I didn't vertically translate. So they're still the roots because they would still map onto new roots. And I still see the symmetry around the roots there. So that actually looks really good. Now I can go ahead and sketch this. Let me move my table of values down here. I just wanted it next door so that you could see it as I put them on. And now click there. I'm going to zoom in a little bit. And I'm going to plot my new points. So I had 2, 18. That's off the scale. But I had this point here that it shares. So I'm just going to do a little loop around that. And then there's this point at 0, negative 6. So 1, 2, 3, 4, 5, negative 6. And then this is also a root. So that's going to be a really now steep parabola that's down here. So let's take a look at what happened. Okay, and let's take a look in Desmos. So now I've finished all of these things. I've applied my transformations point by point, and then I can sketch the new function. I'll show you in Desmos here. Yeah, I couldn't plot 2, 18 because it was off the scale. because I horizontally stretched it way out there. Here was the original function, f of x is equal to this guy. And so Desmos tells me that, yeah, we had it right. It had these roots at 1 and 3 and a vertex at 2, -2, and the y-intercept here at 0, 6. Then when we mapped that point 0, 6, we said it went up to 2, 18. So let's see if we have 2, 18 on the parabola here. Here is 2, 18. We got it. There it is, 218. So that one reflected in the y-axis and then moved 2 this way, and it was also stretched up by a factor 3. Okay? So all of the points individually mapped in those directions. The vertex came down here. You see it was stretched by factor 3 in the y, reflected in the x-axis, and then moved over here too. And the roots, this root was reflected in the y-axis to over here and then moved 2 this way. This root was reflected in the y-axis here and moved 2 this way. So it mapped back onto itself. And so those are all of our points, and that's what our sketch will look like. And so then we've done that correctly. Now, here, we don't need this. But what I could do now, yep.
Can you do the same thing but take it and see if k changes the
So there, it's a negative k. That's removing the negative k. And so if I don't have a negative k, you see this -2 here, this -2d, it moved it 2 to the right. It added 2 to all the x values. So these two roots, they moved over by 2. The vertex moved over by 2. But then everything was stretched by a factor 3.
Now it's by getting rid of the negative.
That was by having a k of 1 instead of a k of -1.
Okay.
Yeah. So I deliberately chose a fairly complex transformation that has 3 transformations we needed to apply, so that you would see how I just go through point by point. And what I do is I build a little formula for myself. That's my x values. I'm going to make them negative and then add 2. That's my d of -2. It's a sign flipper. So it's add 2 to all the x's. Here the a is 3. So I just multiply all my outputs by 3. And that's the only transformation that I do. I can transform all the points according to this little formula. And then sketch the new transformations. Sketch the new functions. Last thing I asked you to do is now review calculating inverses. Oh my goodness. So you're not going to do this today. We're going to do that tomorrow because we don't have enough time. So questions about how to apply these transformations, excluding this idea of finding inverses. So you can do these questions. Don't worry about this. You can do this question. Don't worry about that. We'll come back to that tomorrow. Okay, give it a go. There's a graph paper up here if you want to have beautiful sketches of your functions. For some reason, my hand-eye coordination is not there today to sketch a parabola. I'm very embarrassed as a math teacher that I can't do that, but I am approaching this technology with a growth mindset. And what else to say? Oh, make sure the questions go back that we're thinking about what we want to ask Mr. Kushner when we meet with him. So you have that question sheet there, Camden, that you can start. I see that the questions have departed the front desk here. That's perfect. And I'll collect them from the back of the room when they finally reach there.
Are we